this talk will briefly go through libp2p interfaces, and it'll actually begin with a look at how libp2p ends up getting used in other programs first, and how we're architecting things. And then we'll go through kind of the current direction that we're thinking about standardizing interfaces across the project. This part is this kind of cast in terms of IPFS for a moment, but Filecoin is the same thing, and other systems might do the exact same thing here. There's a core implementation of a system, and it has some protocol APIs, and it has some client interfaces. So these client interfaces would be the users of something like IPFS, the users of something like Filecoin, and so on. The way that we've architected things is that the programmatic interfaces here for the clients get expressed in terms of an API, a programmatic API, which then we use a commands library in Go. I think JavaScript, I don't know what you guys do, which then gives us all the stuff like, which gives us some tooling around having an RPC library to call those commands from anywhere. So think of this as kind of gRPC equivalent. It's not gRPC, but it's kind of that. This could be over HTTP, sockets, and so on. This could actually be any libp2p transport, which enables us to expose a client API to anything. And then that's kind of how other programs end up calling into the system. Now, the protocol side is implemented by having a libp2p node embedded into whatever the system is, and setting some handlers for the protocols. Then each of these is the actual code from those protocol implementations speaking to their counterparts over some libp2p stream. These that are then, of course, muxed together or something like that. So far, so good. Any questions on this? OK, great. Yeah, so it's kind of like the simpler version of the same thing. It ends up being that people just have to, when they use libp2p, or they end up just having to implement this side of things. This is not libp2p related, but that's the same kind of story. So this ends up being some manual implementation, and this is implemented by each. So DHT implementation or PubSub and so on. That's in the libp2p project. This would be on a client of libp2p. So where we're headed is to break apart the interfaces of the systems that we use and use an interface definition language to define what those interfaces actually are and the types of those interfaces so that we can all agree on what the function calls should actually be, and so that we can check things like interface compliance. Now, there might be a mapping. Like you might choose to do something more idiomatic to a language. So we might think about how to do that and support mappings of some sort. But what this interface definition language allows us to do is to then ending up with kind of like code genning out stubs for implementations. Now here I represent libp2p as one interface, but in reality there will be one for like the core of libp2p, and then one for each of DHT, PubSub, and so on. The Kademli DHT, flood sub, and all of those kinds of implementations. And I'll show you. I'll jump in a moment into the kind of interfaces that I'm describing. And so once those stubs are generated, then people can just implement them. Now, again, this can mutate and change over time and eventually diverge. To some extent, ideally not. We would like to keep everything the same because that makes it easier to reason about and test so that clients of these systems can write against these interfaces and then expect that these implementations match them. But there are potentially some cases where this might need to change. In JavaScript, it's the same thing. Even though there's no typed interfaces, this could cogen out just normal stubs as functions.
We have been using tests to try to do something similar.
Yeah.
We have interface definitions on JavaScript and then this test suite that checks if the interface was allowed. So your routing is probably 3 months.
Yeah, but are you testing it against the Go implementation?
against the JS one.
You're testing it against, what is the source that you're testing?
So, like, because we have multiple transports and multiple stream maximums, we have test suites. For example, for stream maximums.
Yep.
We run against all the implementations to make sure that all of the modules that claim to be libp2p compatible with stream maximums do actually comply through testing. Instead of like.
Yeah, that's right. And we have that in Go too, but that's like a stream muxer specific thing.
No, we also have for all the other ones.
Okay, got it. But that's only a thing that JavaScript is doing. It's not language independent.
We never managed to converge with Go.
So what I want to show you is.
Oh, okay.
I wasn't recording the screen, so now I am. So what I'm going to show you is a draft version of what we're working on. So don't take any of these types too strongly, too hard, or whatever. I'm going to define these very quickly. These are kind of like external types that we're going to pull into libp2p, and then out of this, we're going to construct libp2p. We used to be able to just get away with multi-hash for PRIDs. There's a reasoning that we might need encoding as well. But other than that, you can really think of like these two being the main things that we're importing from the outside world. This ends up getting used by something else, like the record store, which I may not even go into today. So kind of you don't really need to think about it too much. Probably do you prefer to go from the bottom layer up, or do you prefer to think about it from like the client side down?
Client side down.
All right, great. So we're thinking of this as the main interface for now. Again, don't get too sold on these types just yet. But a libp2p node would have an ID, which is the peer ID, would have an associated key, which would be a signing key. I'll get into what that means in a moment. It would have a peer store, which is the ability to understand information about peers. It would have a switch within it. It would have the ability to mount a protocol. Now, this might be an idiomatic thing. In Rust, it might be compiled. So we have to think about like what this would look like. And it has the ability to connect to other peers. That's pretty much all it does. Those peer things are, the peer IDs is like the content address of a key. So multi-hash. Here, if it's CID, then it's a little bit more, but that's about it. The peer store is just you can think of it just being a map from peer ID to these peer infos. There might be other stuff. I think the Go implementation and the JavaScript implementation have other things in there. It's not clear those need to be part of the interface. So that's like all a client of just the libp2p node might need. Most protocols that use libp2p might just use that. But we might have other pieces. So this is where the classes of protocols come in. Peer discovery really is just an interface that has a function, discover peers, or a Rust trait or something, that gives you just peer infos, just emits peer infos on its own. That's all it does. So an example of this would be local DNS. You can be listening in local DNS, and it emits peer infos to you. Peer info is the peer ID and the address. Does anybody have another example of a peer discovery protocol?
You said DNS, random walk.
I said MDNS. So what was your example?
Random walk, just random walk on DHT and finding peers as we go.
So another discovery protocol might be, if we have a DHT, we could use a DHT to randomly discover peers on a DHT by issuing random queries over it. So a DHT, which we'll see in a moment, could satisfy this as well. What else could satisfy that? Hey, other people for a moment. You're like that kid in the front of the class. A static list, absolutely. We could. This is like the bootstrap set of nodes. A static list would totally implement this. How about DNS? We could have a specific set of DNS servers that could return records that have this, like text records that could point us to that. What else? What other things could we use? What does BitTorrent use for peer discovery?
Trackers.
It uses trackers, so you could have a tracker type thing. What else does it use? It uses 3 things. Trackers, DHTs. What is the last thing that BitTorrent uses?
That's routing.
Nah.
The random walk is the discovery.
The random walk discovery. BitTorrent uses a thing called PEX, peer exchange. I don't know if you've ever heard of this. All it does is randomly, other BitTorrent nodes will tell you about other BitTorrent nodes. They're not even guaranteed to care about the same torrents you're looking at. You just find out about other nodes. What other things might emit peers? How about Bluetooth ambient listening? You can be in a room, and if I want to tell the world that I'm listening on libp2p through Bluetooth, I could do that. And somebody else listening on Bluetooth could do the same thing.
I think the important definition of peer discovery is that it's peers that you find, but you don't necessarily have a purpose to find them right away, which is different from peer routing.
Yeah. So let's look at peer routing for a moment, and then that'll distinguish them. So a peer router is an interface that just has a function called find peer, where you give it a peer ID and it returns a peer info. So this means that the client of a peer router is explicitly telling this thing, I have this peer ID, please return me a way of connecting to this peer. This is explicitly trying to find a peer. So this would be in a DHT asking to walk along it to find a specific peer and try to connect to that one. What would be another example of this find peer?
I'll claim that the tracker is more peer router than peer discovery, for example.
A tracker is not, because you're not asking for a specific peer ID. A tracker, you're asking for content, and then you just get a bunch of peers associated with that content. That's like a provider stuff. That's even harder. Volker.
Is the peer ID always unique also to the interface? Like for example, if I have a phone, it could be Bluetooth and Wi-Fi. Would it then have the same peer ID? So basically, if I do a find peer, could I find the same device with Bluetooth as well as with
Yes.
Wi-Fi?
Your libp2p node would be bound to multiple interfaces, and you could end up with the same node, yeah. So you talk about Wi-Fi. Yeah, you could totally actually do find peer on Ethernet. Does anyone know what ARP is? ARP is effectively this, just at Ethernet layer, right? ARP is saying, hey, who has this IP address? Who has this IP address? And then a MAC address responds, I've got it. That's it. So the idea here, though, is that these interfaces can be implemented by much more concrete things. Like a DHT does all of these. But the important thing is it's useful to think about it kind of like a matrix where you have like peer routing or peer discovery, peer routing. And so MDNS gives you this, gives you this. A DHT gives you this, gives you this. But of course, like gives it to you with completely different guarantees, right? Like of discoverability and efficiency and all sorts of stuff, right? And so the reason peer-to-peer systems have to do all this stuff is that they have to use as many advantageous tools as possible to try and work in a variety of contexts, right? So something like FireChat is supposed to be capable of finding other phones and communicating across other phones, which is only capable of doing things locally, doesn't necessarily have access to a global DHT, right? So one insight of libp2p is to instead of only thinking about implementing distributed systems or peer-to-peer systems in terms of each of these protocols horizontally, which was the past, this is how BitTorrent and other things think about it. Let's actually think about it in terms of what you need. You need a system that can do peer discovery. You need a system that can do peer routing, and so on. And then which protocols you choose depend on the context in which you want to use the system. Other examples of this that are like less DHT oriented. How else might you do routing? How else might you do peer routing? I could just ask an HTTP server, right? I might have a huge cache somewhere that we agree on. And I could ask that cache to just give me like the last version of something that they've seen. Or if you know that you have a long-lived address, you could write it into a blockchain. Like you could do that for some addresses. Like a Tor hidden service, you would do that. You would take a peer ID and bind it to a Tor hidden service and like commit to it forever. So you could do that, right? You can think of a DHT as implementing each of these things. Now, where it gets a little bit funkier is sorry, I have like a bunch of other pieces. So this is kind of like the higher levels of libp2p. It might make sense for a moment to step into it and look at like the network, because that might be kind of where some of the interface questions are. Right now, this is kind of what the network is. There's a connection. There's a local endpoint and a remote endpoint and a transport of choice for that connection. An endpoint is just an ID, an associated key, an associated signing key, and ID key, and then an address that is pointing to that endpoint. You have encrypted connections. You have connections that can mux, which gives you multiple streams. And again, this is like very Go idiomatic. So while a lot of us like these interfaces, they might not be the ones that all of libp2p needs to commit to. We have a concept of a dialer. We have a concept of a listener. We have a concept of a transport. Transport, allows you to dial into things or listen to things. And then we have the switch. And the switch is what does the heavy lifting in terms of the interfaces and the network stack. And so this is, again, internal to libp2p. Most people don't ever have to worry about this unless you're implementing it. But the switch is what handles a node binding to multiple interfaces, multiple transports and multiple interfaces, dialing, and doing like the protocol muxing. Any questions so far on this? This is like a lot embedded into this. I wanted to talk, so we talked a bit about peer routing. We haven't talked about IPNS. What were the other things? Specs and compliance. So what we want to end up with is a single file that's like this for the core of libp2p, and then a file for some of these things. Like a DHT, it's not necessarily the core of libp2p, but peer routing and peer discovery is core to libp2p. So we would have one file that like describes the interfaces that we agree on, and then find some way of making sure that implementations and interfaces match to that from a client side. And then we need the same from a protocol layer standpoint. Like we want the protocols to be interoperable, and we need to find a good way of writing a language-independent test suite that does that. So I think David wrote about this of creating traces of packets that could then be replayed against an implementation just to make sure that it works correctly. Yep.
So I don't know how much you want to do presentation versus kind of discussion, but I think that it would be great to hear feedback from the audience, positive or negative, about this whole concept that basically a set of .go files like this would replace the specs repo in effect. Like this would become the standard to measure conformance against the libp2p. And it would be interesting to hear what JS and Rust think about that if they have any reactions.
But we need a specification for the protocol for what is transmitted over the network. We need a specification for that.
You mean you need the wire protocol, or?
Yeah, just in general, this is more like syntax. The question is, where do the semantics come from? Like the actual workings of the protocol, they need to be specified as well, and this wouldn't give you that. So you can't take this and replace the existing.
Yeah,
space.
you're right. Replace was, I think, was the wrong word. Supplement, or this would be the beginning of the specs repo, and then it would be followed by textual descriptions of what these mean and what behavior is expected from each function.
There's absolutely no way we can implement this directly in Rust, for example. Like this is far too foreign to Rust. It doesn't say in which thread things are running.
Wait, so couldn't you write a trait that says content discovery and has a function associated with that?
No, because we need to know in which thread the thing is running, for example.
No. So just the ability of having something that responds to a content discovery query. The reason for this.
Why can't that be choice, implementer's choice, what thread it's running, and why can't the implementer decide?
Because that is something that we worked on, and we do have both interfaces side by side.
Yeah, go for it. I think we're getting hung up on different kinds of interfaces. So you guys want a protocol level wire protocol test suite that can ensure conformance across all the different protocols, right? That's kind of like what you're going after?
Like while working on the code, we need to know what the other implementations are doing without having to read the other implementations. But that's what we need.
So let's see. No.
When you say what they're doing, you mean at the wire level? Because I think you're bringing up you're bringing up semantics and you're bringing up the wire protocol. Is that right?
If you run a Rust node and a Go node and they fail to communicate with each other, we need to know which one is correct and which one has a bug.
And I think that would be achieved by having a test suite that has a trace of messages to be able to send to the Rust implementation and the Go implementation, and each one of them would pass or fail, right?
Yeah, that's a good solution.
So yeah, this is what we did in the past, right? So for the interfaces thing, we really knew that like it was hard to achieve the same interface in Go and Node, especially even like in JS. There's multiple things that you can do, and the interface already changed. But like we have the intention of like what needs to dial and create a stream, and then we specify what is the interface in that language, and like it explains what the method should do. So this doesn't do any code gen, it's very manual, so like it kind of sucks. But at the same time, it gave us a language that we could agree on. So now we have multiple stream masters in both languages. And we also do have this for transport, peer routing, peer discovery, and all the others. But this is the one that got a little bit more polished, like a little bit more work on. Then the other thing that we did also, again, to solve that problem, is this thing that we call protocol-driven development. And it's what Juan is talking about having some kind of like implementation that becomes the reference implementation, or like something that like we transform from spec into implementation, and then given that that implementation will output something into the wire, and like the wire independently of each JS, Rust, Go, Haskell, whatever, has to follow the same structure, you can grab those packets and like just throw it into another implementation, compare the output, and get a little bit more certain of what's going on that implementation, if the things are going wrong. Of course, like that doesn't tell you exactly like if there's a bug. You just know it's wrong. Like you don't know exactly where that program broke. But,
and I think I'm suggesting a more extreme version of that, where you have test cases associated with a sequence. You have a sequence of operations, like setting up a connection and trying to open a stream. And then you have a set of packets associated with that then run against one implementation and say, oh, look, you can't open a stream. That's broken.
Yeah.
Right.
So we did like that for multi-stream stuff. It was kind of like the example of like using this approach. Like we defined a bunch of instructions that we wanted to do, and like we created the outputs and inputs, and like we compared both implementations. We actually found like a bunch of issues through this process. It was valuable. It was like very expensive in time, because you have to now write like all the scripts, and like you have to write the tests, and you have to like write the things like just to consume in both implementations. It would be great if all of these pieces have somehow a CLI, like a standard interface that we could just like pipe stuff in, but we didn't get there yet. But it definitely helps. Like all of these things that definitely get us closer to get like compliant implementations. Go for it.
Is this like a one-time test you did, or do you run this against every PR now?
It is we don't run it against every PR. Like it's not a repo, but we haven't run this in every PR.
But we could wire up one of those services.
We could totally do that multiple times, like, and even before release, like we should definitely test that against what's going on.
So far we're talking mostly about wire protocol agreement. What the other interfaces are about are the other things that are about modular interface agreement, which is if somebody else wants to write a thing that could be plugged into a libp2p node, they need a set of standard interfaces that they need to match against to be able to mount that protocol into things, right? So in Go, for example, if somebody wants to write a new DHT, they can totally do that. And as long as they have something that exposes the right interfaces, then they can mount that whole thing into libp2p, and then an application can use it. And so that's a different type of interface. And even that is different from like the client, right? So this node thing that I showed you, this is kind of like the client interface. Whereas this classes thing I showed you, this is kind of like the modular interface, where by agreeing to create a modular interface like this, then we enable people to write these different implementations. So they can be plugged in. Does that help distinguish and separate the concerns?
Yeah. No, I mean, just a comment on the modular thing, on the modular API in Rust, we've used a totally different approach. So like in Go and JavaScript, you have like this piece of codes that are interconnected together. I mean, that's how I see it. While in Rust, we have like DHT, ping, identify, blah, 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 all only connected to the user code. So they don't need to know each other's interfaces. Like only the person who plugs the protocol needs to know the interface of the protocol itself. So we don't need to standardize anything. We don't need peer discovery.
So how would a new person who is not you write a new DHT in Rust and plug it into say an IPFS node in Rust?
So you'd write the DHT and then you'd have to write the plugin yourself. That's not very complicated. Like in what you're explaining, the DHT and the IPFS thing are plugged with each other with one of these interfaces. While in Rust, what I've been trying to do is that the user writes the bindings between the two.
So we're getting to a point where IPFS won't know about a DHT. IPFS will know about peer discovery and content discovery, and will write against that. Does that kind of make sense?
Yep.
And so if you import IPFS as a library, and you import libp2p as a library, you can say, I want an IPFS node that speaks with a Kademlia DHT.
Yes, I see your point, but what I mean is that in my mind, the IPFS library would have these traits, and the user, the person who plugs the DHT on IPFS would implement these traits themselves. So we don't need to standardize them. They would be
so then somebody who writes the DHT has to be the person who plugs it into IPFS, and then somebody who's writing a different application can't leverage those traits. They would have to write the traits again.
Yeah, but that looks like a problem in what you're saying, but it's not.
Okay, so I think we should discuss that more in detail, because it is an explicit goal of libp2p to enable parties to implement things that are pretty hard to implement, like a whole DHT or something, and enable people that are application developers to just write against these interfaces and allow a separate person altogether to easily plug those two together without requiring recompiling anything necessarily. Or without requiring modifying code anywhere. Maybe recompiling libraries, but like if I'm importing those as libraries, then I'm going to recompile it in my program. But I should be able to like connect these like Lego bricks.
Yeah, but this would add an overhead, in my opinion. Like
What is the? I don't understand the overhead in Rust. Wouldn't that just be compiled away?
No, but what I mean is that if you want it to be, well, yeah, I need to think about this more. Like, if I say something right now, it may be wrong.
Okay. No, but totally
We
makes sense.
Talk about it more on GitHub issues. I mean,
yeah, let's defer it out.
On the table.
And I think Steven might be a good person for this because he comes from like Rustland more than Go or anything else, and he's thought a lot about these interfaces. So may want to talk to him about it. Whoa.
So I just want to. So David, how do you feel about this for JS? Is this like if you had a set of Go interface files and wrote a code gen tool, would you just be like, yeah, this is awesome?
Yeah.
Okay.
I've been pushing for this since the beginning.
Okay. Okay, cool. I didn't know.
Yeah.
All right, so
But we still need the wider protocol tests,
Yes.
and we also need the interrupt tests. Like one of the things that is happening on JSLand is that we have an interrupt repo, and right now the interrupt tests are written in JavaScript, and we use the client libraries to talk with the Go IPFS node and the Just IPFS node, and I just orchestrate them, and I just get them to do things together.
Mm-hmm.
But like it's not the most efficient way, or like it's very verbose. Like to write JavaScript to tell different implementations to do things. It would be great to have a language that could just describe what a node should do, and then like that language could be compiled into CLI code that then runs against both nodes.
Oh, I see. Yeah.
Something like that.
Yeah. That makes a lot of sense.
And
Yeah.
like if we create a similar thing like a libp2p daemon, so right now we have libp2p nodes. Like we create in-process instances of libp2p. If we have a libp2p daemon with an RPC interface, then we can do exactly the same thing.
Yes. I see what you mean.
people asked about IPNS, and I wanted to kind of describe how that works. Are we interested in that, or do we want to stop? Yep.
If I'm the only one, though, I already know about it a little bit. So,
who else is interested in this? A couple people, hands. All right. So, summary of like IPLD. You have content address things. So you have byte sequences, which represent nodes in a graph. This graph is linked through hashes. These hashes are expressed as byte sequences called multi-hashes that express the function that you use, the hash function that you use to compute it, and how to move forward. IPLD is a set of libraries and formats to be able to read arbitrary data structures that follow this hash-linked thing, to be able to traverse through links across different domains. So for example, there's a cool talk where Jeremy shows ingesting all of the Zcash chain into IPFS, and then is able to traverse the Zcash chain with a path notation similar to how you would in a file system. And that's kind of done through IPLD. I'm giving you like this tiny little primer to then express how the rest works. All IPNS is a name system where we're mapping a key, so a public key, a cryptographic public key, and we're treating that as a name pointing to a value that can change over time. And the idea is that we need some place to write those records, right? So if I want to mutate a name over time, I need to be able to construct a record. So I need to have my private key associated with the public key, write the value, and then write the signature on that value. And I need to bundle that up and put it somewhere that somebody else can look at it. to be able to find it and resolve it, right? So this is kind of similar to DNS in a way that DNS is not secure and it's not signed, but it has the same idea of like putting little pointers somewhere where you can use a name to resolve the name and get the value, right? So it turns out that a lot of peer-to-peer systems use this idea of like little records somewhere that tend to be cryptographically signed for a whole bunch of purposes, including like advertising like which trackers you should go look at, showing bad behavior in certain nodes, saying that a particular node is storing something. All kinds of stuff end up boiling down to the idea of being able to express a very small record that has some meaningful semantics in a system, but is usually meant to be posted somewhere that a lot of people can look at. And so we think of that as kind of like a record type that has some value and some ability to check a validity associated with it. In IPFS, we have three kinds of records. We have address records, we have provider records, and we have name records. So the address record would be a node advertising to the world that it has a specific set of addresses and being able to place that somewhere in the world where you can find it. The provider record is a node advertising that they are storing and are willing to distribute some piece of content. And the third one is a node is advertising the next value in some pointer, right? Like that's the name. We've thought about using this kind of record structure to advertise signed heads of CRDTs. So you could use the exact same kind of structure to have some public searchable space where parties like create a record and say, hey, this is like the last value of the CRDT that I have. Not the whole log, just the last value. And then that would allow parties to like find that record and then find the other, and then maybe find the address records to then connect to them and synchronize. Actually, I forgot one, the pub/sub stuff. We have a fourth record, which is in pub/sub land. You need a way to advertise channels and channel membership. So you need to be able to say, hey, I'm going to create a pub/sub channel around topic X, and I'm this peer and I'm interested in this topic X. So it's very similar to the content, but it has a different semantic thing, right? And so in IPFS land, we end up using a DHT for a lot of this stuff. But the basic abstraction is you have all these little bits of information that help groups coordinate, and they're usually signed, and they're usually, the expectation is they can like exist somewhere, and there's going to be a lot of them, and they're transient. So we have a thing called a record store, which is what is an abstraction that like addresses all of that. So given a record store, which is just like, you can treat a record as just like, again, an IPLD thing. It could point to other stuff. It could be signed. And it could be validated. It has like a specific interface that needs to be met. Given that, you can implement naming pretty trivially by just setting the value and then posting it to whatever record store you're using. So in the DHT case, it would be an IPFS node, has a key, signs a value, crafts a record, and then throws it onto the DHT at the right spot. And so if you want to resolve it, you ask the DHT for that record, and then you find the record, and then now you can use the name. Now there's a whole bunch of questions there around, are you getting the last version of that record? Are there others? Is it getting silenced? There's a whole bunch of security questions embedded in there. And there are also performance questions. A DHT, resolving over a DHT kind of sucks. It's pretty slow. And if you also disappear, your record may not be republished for you. So a DHT is good for some use cases, but it's not good for like the really high performance stuff, and it's not useful for long-term persistence. So for long-term persistence, you could easily take those records and put them somewhere really persistent i.e. something like a blockchain. You could actually throw these records straight into a blockchain and write you could write a record store on top of any blockchain and throw these records on Ethereum. Like, there's already people already doing this. I think Uport experimented with this, and they have like an IPNS thing where you map an Ethereum address to a name. So that gives you persistence, but not the high performance. The high performance thing, you could actually treat PubSub as a really weird record store. You could say, I'm just going to take the latest value and just propagate it over a PubSub channel. And if somebody's listening, great. And if not, whatever. It's just ephemeral. It's gone after I sent it out. So now, with the name system, if I'm updating my name, I could, if I want this update to persist for a very long time, I put it on something like a blockchain. If I want this name to persist for a medium amount of time and I don't care that much about performance, I throw it on a DHT. Or if I want things to be really fast, if I'm going to make a lot of updates really quickly, I don't want to do either of those. I want to throw it over PubSub to people that are interested in this name right now. And so that's how, if we write this one interface, then the rest of the stuff can flow out of that. Questions? There's a lot in there. I saw a bunch of people nodding, so. Actually, you could use CRDT for a record store too. So yeah.
How do you see the migration from the current records of your
How do I see it? We just need to agree on an interface and then ship it. Yeah. Yeah, I mean, I think, so for the longest time, we were waiting for a lot of the IPLD stuff, language stuff to land. I don't know when that's going to land. So if we want to just use some, like a Go struct or something to define the type, I could roll with that.
Yeah, because the difference, or the key difference would be that records will be referenced by SIG. As soon as we, like, even if just moving this to support them, make it control whatever comes next.
Yep. Anyway, let's probably figure that out offline because there's a lot of like context there. Any other questions about naming? Otherwise, see you. Thank you so much for coming. Yeah. There. Does that demystify naming? I mean, I can demo it. Like, this is still pretty abstract. So when I create an IPFS object, it has a particular hash, so I can look at that object. I should be able to look at it in the world. Will it work? I don't know. I don't know what the like NAT traversal story looks like here. All right, I have a lot of peers. Will it blend? All right, great. So whatever gateway I hit first didn't find me, but now this one did. So it's there. So now it's in another computer. So now I can take a name and I can publish that hash as the name. And so this is creating the record, signing it, and then posting it. In this case, it's posting it to the DHT. Why does this take so long? No idea.
It has to reach 20 nodes.
It's like stuck dialing something that like it's non-dialable.
Or is just too many nodes.
So theoretically, it might already be in some nodes, right?
Yeah.
Nope. Yeah, something is like majorly stuck there. Oh, what? I think I'm connected because I'm connected to like 200 nodes. It might just be really slow. It might just all be stuck in like crypto handshakes. Oh, there we go. So now this should resolve soon, right? I shouldn't have to refresh, but what if I hit another one? One of them worked. So that's like non-human readable names, right? Because those are keys. IPFS also has the ability to use DNS as a name system. So this is how this is how our websites work. So if you've been to any of our websites, like PeerPad, that is not a normal HTTP server. That is an IPFS node. And the way it works is that if you trace like the traditional, what the browser is doing is that it's sending an A record to peerpad.net, which is sending a DNS query for an A record. I'm going to do it with short so you see it. So this is like the response that I get for peerpad.net. So the browser would be dialing to that. It would say, hey, what is that? But that returns nothing. That IP address returns nothing because it is an IPFS node. So when your HTTP request, when the browser calls that, when the browser goes to peerpad.net, it also sets the host header in the HTTP request, right? And so when the host header is set to peerpad.net, the IPFS node will just translate that to this. I don't know if you guys can see that. I'm sorry that I can't increase the font size here, but that's just the IP address /IPNS/peerpad.net, and that resolved this content. Sorry, let me invert the colors. Is that better? Here, I have a plan. Can I go smaller than 720? You can see that, right? Yeah. IP address, the rest. So the way that this works is that behind the scenes, that IPFS node is running its own DNS record check. Whoops. Come on, man, standards. No. So I can take this, and now, so what's going on behind the scenes is that it's mapping that name to this. Sorry, I'll open in a new tab. And so that's how I get this content. So we went from a normal human readable standard HTTP link, talking to some server out there, telling it that we want this name. That gets to this hash address, and now it can serve it to me. Now for the kicker, you can do that locally. So look at this in localhost. So this is the exact same content. going from localhost, which is my local IPFS node. And that would be the same stuff. And the really cool thing is to see it working with the same pad. So let me show you. I'm going to open a pad here. What? So I'm going to say, hey, what up? And then I'm going to take the rest of the address and then go to localhost and view it. I guess I need to open in this, right? OK, so that. What's that?
Yeah, there were some issues.
Incognito does not work. It has worked for me in the past. Well, let's see if it works. If not, I'll open Firefox. Great.
Where's Safari? That's why we were seeing Safari, no?
Sorry guys for interrupting. So we have to go. You guys need to catch each other. Okay.
Thank you.
Will it work?
Thanks for having us.
Yeah, absolutely.
Yeah,
Are you going to the block? Are you going to the block?
Are you going there? We might have dinner around here.
We're all paying attention to what has turned into be a very short conversation.
Hey!
It appeared.
All right.
It took a long time. I think that was probably WebSockets, setting a WebSocket connection, doing crypto channel, then asking that node to relay a connection to this other node, and setting up a crypto channel there. All with RSA, I think, right?
Could also be just a rendezvous server being slow.
That could be too.
Yeah. And also talking about
There we go.
Wait.
Oh, and Incognito did work.
Oh, it did? Nice.
So all three of them worked. Eventually. Yeah, so that's how the human readable IPNS stuff works. It's really DNS. You know, don't really need to reinvent a new human readable name system yet. And there are others like ENS and so on could do that. Any questions about any of this? Yeah.
Not a question, but there is a, in the IPFS organization, we just moved the DNS link tool to the IPFS organization. So if you want to set it up with your own like records, your own DNS and stuff, you can find the tool in the IPFS organization. I think it's called DNS simple -DNS link or something. If you just go to the organization, you will see the.
This.
Just go to the organization. It should be in the top.
This?
Yeah, okay, we haven't finished moving it, but it will be there in 2 minutes, as soon as I go back to my laptop and accept the, so that's a tool for DigitalOcean, I think. And then we have another tool for DNS Simple as well.
Yeah, I mean, probably should have like a one that deals with, there's like a DigitalOcean one and so on, right?
Yeah.
Should probably like merge all of them into one.
Makes sense.
Does it require you to have the code installed?
No, it's just a binary.
Yeah.
Basically. The DigitalOcean one is in JavaScript, but then the new tool that we're using right now for like automatic deploys and stuff, it's just a binary that you just download, put the record, put the hash, bam, everything works.
But all you have to do is that, which is set a text record on DNS at that address, and then it'll work naturally.
You don't even, well, you need to set the A record to point to an IPFS gateway as well.
Yeah, you need to set those two records.
Yeah.
They should probably be returning 2 or 3. Oh, is that Anycast?
So you can set the alias to gateway-int.ipfs.io, and then you get like our public gateways.
That
will be useful for the gsipfs.io because we also need to set a DNS record.
Yeah. So
it's being development right now.
If you add the Jenkins file, it just does all that for you.
Yeah. Pedro, you'll need that.
That's how all our websites work.
Yep.
Great. Any other questions on this? Or does everybody understand and is now an expert on how all this works? Yeah, Victor?
Did you talk anything about what the current performance of
yeah, so current performance of IPNS on the DHT sucks for a whole variety of reasons, which is why right now there's an experimental flag in Go IPFS to use pubsub for really fast updates. But that doesn't work if you're not around. And long term, you want it to be persisted into a blockchain or something like that to allow long-term naming to happen. That's a whole other. That just is like a. There's like a little. We should get into a point where people can write these different resolvers and publishers across all these other systems. But I don't know when that is gonna happen.
Maybe it's because of my. I'm quite new to this technology, but what's the policy in terms of changing the naming? Like, if I don't have access for that, or do I have access? Can I change it? What's the policy?
So with a normal DNS name, then it follows whatever access policy DNS has. So if you can change the DNS record, then you can change the name. With the other one, the key name, which is not human readable, then it's whoever has a private key. So in this case, it's my node, so I have the key here. You would just have to share that key to another party.
So
yep.
There are two different keys you can publish the IPNS record to. First, you have the node identity key, which is probably what Juan was using before. But then you can also generate new keys, right? Because I think if you use the same node ID key on multiple nodes, that kind of gets confused. But if you generate a new key, you can share that key, and multiple people can use that key to update like the same website. But it should be a new key, not the self key.
I think there's a way to do key gen, or no?
Yeah, it's on the key, IPFS key, I think, or keys.
I think that feature is only on the IPNS not on because itself. And also, like, there's no.
It is on the IPFS name. It's a -- key parameter.
Woo! I have a key. So now I should be able to publish to this, right?
Yeah, with -- key.
And now we wait. Still waiting.
Yeah, and right now it's not implemented, but like we can also have a key that creates a record of like all the other keys that can publish that name. So then you can have records that can publish. Because the way that, like the really clever thing here is that like when you publish into the DHT or to the network, you don't publish on the hash of the record. You publish on the hash of the public key. So if I can generate a proof that I'm authorized to update that record, I can still update. I can still publish to the same location, so you still will find it as well. And then you just have to validate the signature, and then you will accept it. And that comes in with IPRS. So you can have like a circle of publishers, like of authors.
This is stuck because while it's walking the DHT, it's setting up a whole bunch of new connections, and some of those nodes are not dialable. And right now, that dial operation can potentially take a very long time because it'll try a number of addresses until it stops. So that's what's making it. This is totally brain damaged. Like it could be way, 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 way faster. It's just stuck waiting. That and Quick and a number of other things will like vastly speed this up. So this is buggy. Needs to be fixed.
someone had asked how does IPNS works? Is that question answered? Is there any part? Yes, it is.
Hasn't finished. Resolving.
We never got to the streammuxing stuff.
Yeah. Do you want to talk about streammuxing?
So David and I talked about this yesterday a little bit, but basically, well, do you want me to restate the question was about HTTP2 versus Speedy, which I'm just repeating what I understand here. I think Speedy is deprecated now, but we can't, if I understand correctly, we can't use HTTP2, which is supposed to be its successor, for a couple of reasons. Which first, there's no node package yet for HTTP2. A second issue was it would make NAT traversal harder, and it also doesn't, there's no way to use it yet with TLS 1.3, which is kind of a requirement for us because we don't want to have a CA.
But eventually published, but yes, I think it also bundles in a whole bunch of stuff from HTTP land, which we could ignore, but that is non-trivial. I mean, the Go uses Yamux to talk to other Go nodes, and then it uses Mplex to talk to nodes multiplex, I think, right?
Mplex.
Yeah. So there's two different muxers. Like if we find something that is compatible from Rust to JS, and we find something else that's compatible from Rust to Go, then it'll work. We wish that it would be as simple as saying, oh yeah, just use HTTP2. We have learned the very hard way that stream muxers are not easy to implement, and they are quite tricky when you have hundreds to thousands of streams in a long-lived connection. And most implementations that we've ever found are buggy in some ways. We've fixed a number of them. We've done pull requests in most implementations that we found. So we hope that Quick will solve a lot of this, because Quick is a standard that a lot of people are moving to. I wouldn't bet on any HTTP2 implementations, because I don't think HTTP2 implementations are put through hundreds to thousands of streams like we would do. I don't think, I mean, what I'm saying is we can try that out. It is likely the implementations we use will be buggy, and so it'll just be a long haul of fixing those bugs, which we can do. It's just a matter of finding, do we want to fix bugs in HTTP2 or do we want to fix bugs in Quick?
Well, so I think that, sorry, I should have prefaced the question. The hope is that Quick becomes the primary 95% use case, but we need a TCP fallback for the other 5%. And then I think that's where this question comes up. Yes, to you.
So I did get also the chance to check the VPN after. And so the key thing about the VPN is like when I discovered some node, I learned about all the addresses that the node is available. And now I have the power. I am able to make a decision which transport I'm going to use, like which combination I'm going to use. And it's not that we are going to have a default one or a primary one. Of course, like if all the nodes in Go IPFS and just IPFS have Quick, then it becomes more obvious for like a third or fourth implementation to also have that transport. But the reality is like not all the runtimes will have Quick. In the browser, we will not have access to Quick for a very long time, because we cannot access, for example, the keys that Quick is using. So what happens with our RTC today is that our RTC does DTLS check, a crypto check, and then we have to encrypt again because we cannot have access to those keys. So we are doubly encrypting things without actually needing it, just because we need to authenticate the connection. So what needs to happen is the language implementation should actually make a decision based on their best implementation. If the Rust as the if the TCP WebSockets or RTC Quick, if Quick is the best, they should just use the best as a primary attempt. But they can also simultaneously try to open connections in all the transports at the same time, and then test. Because WebRTC can be using some relay, and if you have a WebSockets connection on WebRTC, perhaps the WebSockets will be faster because it's direct. Then there's also another thing which is we peer-to-peer circuit relay. So when I'm dialing to you, I might have a TCP. We share a TCP transport, but I also see on the list of multi-under that you are on a separate relay. but probably you always want to leave the separate relay transport to last, because that automatically means that you are routing your packets to some other node, making it slower. Potentially not, because the internet is weird, and sometimes the connection is actually slow. So it's really about like guessing, like trying and like just capturing statistics and heuristics to make good decisions. There is no default one true solution.
So do you think from a specification standpoint, we should just say like any implementation, any valid implementation is required to implement quick and at least one of the following, and it's a list of TCP transports, and you know.
No, like
or how
I think the specs should say, like, in order for a libp2p node to exist in a language, it has to have access to a thing that looks like a transport, a thing that looks like a stream boxer, a thing that looks like a crypto channel, whatever, right? And then you can say an IPFS node has to have a TCP transport, has to have a WebSocket transport, right?
Okay.
It's like a parity node has to have like these transports. Like everyone makes their own recipe. Like, we don't have to say from the protocol what everyone should do.
So libp2p itself isn't going to require any, in theory, yeah.
It can't.
Okay. It can't because it couldn't require you to implement any transport, I suppose. It's not, there's no,
Yeah.
Okay.
For example, you could, so Tor, I don't think Tor does stream multiplexing. With Tor, you get one reliable stream.
Yeah.
But this is something that they would likely, if people use Tor extensively, they would end up syncing that into a lower layer. And so it would be the sort of thing where like Tor, you may have access to the keys that you use with Tor, and that may give you stream muxing. So you don't need to pipe some other stream muxer on top of that. So we need to walk into a lot of this, acknowledging that stream muxing is a big part of connections across the board, and the implementations will vary, and sometimes the lower level protocol will give it to you, and sometimes it won't. Like SCTP, if we used real SCTP connections, like raw, instead of like through WebRTC, we would have access to a stream muxer right away. Mm-hmm. And there are other transport protocols that do this too. So just like the bugginess right now is just simply because these implementations are pretty hard to do. And you know, it would be great to get like a formally verified one that would just like compile into WebAssembly and just use that.
So I just want to, so I mean, I think the motivation for the original question though is speedy being deprecated. Is that actually the case? Or?
Not the case. It's more, we have an implementation in Node that is really reliable. Not deprecated. So, okay, historically what happened was Google created Speedy, they started shipping into Chrome, they proved to the world that like having stream multiplexing on the browser was really useful. They kept developing protocol from 1 to 2 to 3 and then 3.1. And 3.1 was a little bit polished and then called HTTP2. So HTTP2 is just like Speedy 3.1 with some bits like organized in like in different order, but like it's exactly the same flag, exactly the same back pressure, exactly the same control frames, and HPAC. And HPAC is Google saying like we analyze all the web traffic and like the most used headers like this one, we did an Hoffman table, and now we have a very big way to compress, and so that's HTTP2. That's just it. And so Speedy still exists, and there is people like using Speedy to serve their clients. And in Node, there is a really robust application. Like there was multiple companies using it in production for years, and it was developed by like, really good developers. In Go, the case was that there were multiple creations of Speedy, but like none of them was fully compliant with the spec because it was always like very ad hoc to the specific case of the company. And so we don't have a good implementation of Speedy in Go.
Yeah, in Go they went straight to, so the main effort to implement went straight to HTTP2 as opposed to getting really robust Speedy. And there were multiple Speedy implementations that each diverged from the implementation. So Yamux, which we use in Go, was originally a Speedy re-implementation, and they just dropped some stuff. And that's it's just like slightly different.
And so that's why we don't use it today. But when you compare the two, like multiplex and Speedy, Speedy is way better. It's just like multiplex was the thing that we finally got to work across both implementations, and that enabled interop because we never got the Go one working as we wanted. If we get the Go one working as we wanted, then we probably would drop multiplex because it doesn't have back pressure per string.
Okay.
So yeah.
Just implement quick.
What?
Everyone implement quick. Go.
Yeah, but then we don't have it for the browser, which is the problem.
Ask Mozilla to expose the keys.
I mean, the IETF is going to standardize Quick by the end of the year, so the browser vendors maybe. That's what our guy on Quick, Martin, has told me. So he's on the committee.
Who is on the committee?
Martin is on the IETF's Quick standardization committee.
Yeah.
So.
I think so. There is a EITF spec for like how it works internally, and then the W3C is the one that decides the APIs that get exposed to the browser.
Okay.
And so you have to have a conversation as well.
I see. Okay.
And then the browser vendors, because the browser vendors are the ones who are like actually going to do the work of standardizing and implementing, and they'll be. So I wouldn't expect all of that to happen for a couple of years. Like I think we're going to get Quick to use in Go and Node, and we will get Quick underneath the hood in Chrome and Firefox, but not in a way that we can use it nicely. It'll look like WebRTC to us from the browser.
Okay.
And maybe WebSockets. I don't know if they're going to expose it to WebSockets. They might. Yeah, like do WebSockets over Quick. I don't know. It's like such a mess.
Yeah. And so right now, one of the things, there's like design of interfaces that we still haven't really nailed down is how to, like, because we have this smaller thing, like we have a transport, we have the stream boxer, and we have a crypto channel, and like when a transport appears with all the features, we still don't have a very good way to capture like every single property that the transport offers. Also, because some connections, like as a user, sometimes you might be interested in dialing a plain text stream because they're totally fine, like you're broadcasting weather events, whatever. And sometimes you want to have more strong encryption, or like there's like on the interface of libp2p, there should be a way that when a stream is created, all of those things can be selected, and then libp2p like looks at the bundle, the tools it has, and like picks the best combination.
Okay. Yeah. It makes sense.
One question. Is there a library on the user land that tries to upgrade the transport in order to be more efficient to transport large amounts of files, data? Like, for instance, if there's a node that supports 3 transports, I might try the most supported one, or the one like HTTP or something. Mm-hmm. But if it's slower, but there's another faster protocol, is there a way to transparently upgrade the transport?
There should be. We got a lot about that. It's kind of like multi-path TCP, where you can actually also transition. For example, I'm talking to you over Bluetooth here because I'm in the room, and I go to the other room, and now I have to go through the internet, right, to talk with you. There should be a way to do that transition smoothly, and also to just like figure out what is faster. And right now we have like we capture a lot of stats from the connections that we use, that we create, but we are not using them in that way yet. There's a lot of like designing happening.
So there's a possibility there to make that happen.
Totally.
So a lot of this might get a lot easier when we make the packet switching stuff in libp2p, because we're going to be able to get rid of a lot of abstractions along the way. So a lot of these protocols, like the DHT protocol and so on, could be entirely packet-oriented. Yeah.
I ask this because there's the socket I/O or the engine I/O stuff tries to actually start from a more standard connection and then upgrade all the way up. And maybe sometimes it downgrades again.
Yeah.
That would be cool to FS
It's a little bit difficult right now we would have to think about the semantics of transitioning we might be able to like move over protocol by protocol. Like if we set up 2 connections, then moving like DHT streams, like if there's a stream in flight or something, we can't easily interrupt it, because then we're messing with the semantics of the higher level protocol. So we would have to like be able to pause the stream exactly, and then resume it in the other side. or just say that stream sticks on that one and new streams get generated over here. libp2p can handle all of this transparently. Like libp2p could use 2 connections and then mux them in such a way that the protocol has no idea that there are 2 underlying connections. It just would be able to use both. And one of the original dreams is being able to use, say, like a wired connection and wireless simultaneously to like increase throughput of an application, right? So like you could totally do this. And I don't know if you've noticed, but Apple does this with some applications. It uses both LTE and wireless sometimes. So once we get either packet switch, once we get packet switching, this is a lot easier to do from my point of view. It's harder to do when you don't have packet switching and you're doing it with stream connections that you don't really control, like Quick or WebRTC. That gets harder because you can't easily pause it and resume somewhere else. But I don't know, maybe we can figure it out.
I think it can be, or that just by having like a module, like more and more stream controlling, like bringing congestion flow above the stream vector.
Yeah.
So that like whenever a is writing, like the congestion flow now knows how to write multiple transports. So then like each one has its own congestion flow, it doesn't matter, because here is where the packets maximum again into the stream on the other side. Give me that, but like it's still expensive. Yeah. There's a lot of cool ideas.
Good discussion.
Yeah. And you still have the dynamic Hoffman tables.
Fever dream in a train to Maribor.
There's like this idea of like doing dynamic compression, because a lot of like the compression that exists is like, oh, we analyze all the traffic that this type of transport is used for, and so we create now a table, right? Like HVAC from HTTP2 is exactly that. And like when you are talking about like IPFS and the peer-to-peer, you don't really know what's coming. Like you don't really know the types. You don't know if it's encrypted, if there's any patterns. So what you really need is like something that can adapt to the types of things that you're using. And for example, if you're doing a lot of video or I don't know, streaming music, perhaps there's a better dictionary for that. If you're I don't know, just chatting or sending images, there's a better dictionary for that. So what you need is like just analyze the traffic that you're sending, and then often reset the Hoffman table so that now you can compress whatever goes on the wire.
Yeah, assuming the future content is going to be the same as exactly. Yeah, that makes sense.
Exactly. It's kind of like a QoS on the wire.
Yeah.
That was what came into my mind, QoS.
Yeah. So I think, did we write this one in the issue? It might even be a good exercise to just like go through the IPFS history of issues without the ideas and things like we talked about or considered, just to run everyone up on like the places where we have been thinking about things.
Yeah.
And just like to bring those ideas again and enable our people to know it.
Should we try to do that tomorrow or something? Or?
Yeah. Just like scroll and maybe we can do that and then just pick the best ones and present to everyone.
Yeah,
that'd be awesome.
And libp2p is one where there's a lot of really cool things that are not really dependent on a lot of our other stuff. So a lot of IPFS things end up like depending on something on IPLD land or in something in libp2p land and so on. And so it's pretty hard to actually land them. libp2p is full of ideas that are pretty self-contained and can be built on their own. So some of the stuff that I wrote there, like building a Bluetooth transport for Go libp2p or JS libp2p or something like that, is something that could be like completely self-contained, and then build it, ship it, and if IPFS imports it, that's a separate question. And so it's a hope of mine that we can get libp2p to a point where we have like all these ideas and so on, and then people can like attack some of those over time. Yeah.
So we should think about how many dependencies we want libp2p to have. Like, are we okay with it depending on IPLD types? Like, that's what we were showing. I mean, I don't know. I'm putting it out as a...
No, it's a great question.
Yeah, I don't have an answer, but...
I think it really boils down to whether or not we want the record store thing to be formally part of libp2p. We think that it should be for a lot of reasons, and that gets a lot easier if you get IPLD there.
Can you say a little bit about why you think it should be part of libp2p? It's not clear to me.
Because the things like so this is where, really because of this, given a record store, I can implement a content router or a peer router or peer discovery and so on top of any record store. And so it becomes a pretty, if a system implements the record store interface, and then you can get almost everything else in libp2p out of that. So it becomes kind of like a worst case scenario. You can get everything you still wanted out of that.
So it's like a fallback. Like if they refuse to implement other things like pub/sub and DHT, and is that what you mean?
Yeah, and also the other way, for example, a DHT gives you peer discovery out of the box, gives you peer routing out of the box, and gives you a record store out of the box. It doesn't give you content discovery out of the box. We just implement that on top of it by putting content discovery records onto this record store. That's the idea.
I see. Okay. And so the record store has to rely on IPLD types? Just trying to ferret out what are the absolute minimum dependencies.
So, funnily, IPLD exists because of this thing. So we were thinking about this stuff, and we're like, oh, man, suddenly you have different records, and they might be signed by different keys with different validity algorithms. Name is signed, but a content discovery thing, you might want a proof that you have the content. Beyond just hashing it, you might actually want to be able to generate a proof. So a lot of possibilities open up when you can point to code from the records. And so if you can point to code from the records, then you want to authenticate. You want authenticated data structures, and so you want to be in IPLD land right away. And then that's what is okay. Halt. Let's go figure this out, and then come back to do this. So that's kind of where this came from.
So let me ask this: should IPLD be part of libp2p?
Well, it's I guess it's imported by libp2p.
Yeah, but I mean, as a project, would it make sense if IPLD was a part of the libp2p project?
It's its own thing. IPLD is its own project.
Okay, yeah, so no.
No. Yeah, I would say it would be way too much scope creep.
Okay.
Yeah.
Okay, just trying to feel around the different.
No, it makes perfect sense, and I mean, part of this is that this evolved over time because we try to get to deeper and deeper, more fundamental questions about how these things should work. And it's not clear that, sorry, Claire. Yeah, I mean, if we get the record store abstraction really right, and we have the ability to define new record types with arbitrary functions that we can write, then you can do stuff like CRDT merging straight into that. You could do a whole bunch of interesting stuff right there. And so it's a pretty, I don't know, it's a hard rabbit hole not to go down into. Does that make sense? It's
yeah.
It's like the pies look really good, and you're like, oh man. And you fall, and Steven's already falling in there.
I see what you mean, because the way I look around, or my head around libp2p, I didn't quite see the records thing and the IP-RS going inside the libp2p, but maybe an extension point. If you develop a way to extend or add functionality around libp2p, maybe this could be an add-on or something like that. I don't know.
Yeah. It becomes easier to write things like DHTs too. like sometimes DHTs have certain conditions, and being able to define them on a record and have all of that taken care of for you would be easy. Now, I think the hard part here is we have libp2p now, and we want to use it now, and all this IPLD stuff is like not there yet. So that's the issue. Like if we had IPLD and it was nice and as pleasant as say protobuf, then we'd be like, yeah, sure, why not? Sounds great. So I think what we probably should do, like I wonder if we should probably move forward on defining them on top of CBOR and then just dealing with it later.
Sorry, on top of what?
Like we already have IPLD formatting and so on top of CBOR.
Yeah.
Okay.
So we could go in that direction.
We can use like the format. We don't have to use the tag API. Right?
You can still use the tag API. What I mean is this was blocked on Steven and I and others figuring out the like IDL language, L0, to then be able to like, because what you really want is to be able to write something like this. Oh my God, where am I? You want to be able to like define something like this where, oh, actually it's just a signed record. And like, I guess that's almost it. Given that signed record, like implement signature checking. And then like you would have like a DHT that is able to like just implement some function around that. And that's it. This is not a great example. Maybe this, so. You would be able to like implement a name system on top of any record store. And so given like you have a record, so you could write like a, you know, and so the implementation of that name system on top of any record store would be trivial, like really, really easy. And so this is why we're stuck in this kind of stuff.
I understand. I'm just, you know, giving my opinion from someone that comes from outside, and
absolutely.
If I just want to make a connection between two you know, devices. It feels kind of strange to have these things on top of that. That's why I said maybe if things will be more like you could include stuff inside the lead peer-to-peer, just not this kind of stuff, but many others. Maybe it will be more flexible or extendable. I don't know. I'm just
makes sense. It is kind of a tall order to be like, oh, and libp2p, which is already has to ingest all of the complexity of all of the networking world and all of the peer-to-peer world, also ingest all the complexity of all the hash chain world. Like, it's just, Jesus.
Yeah, see, the perspective I'm coming at it from is like, I want libp2p I want to be very explicit in the specs about a conformant implementation of libp2p must implement A, B, and C, may implement X, Y, and Z, you know, like this. And I'm just wondering if the record store thing, it puts a lot of bulk into the must category, and maybe it should be in the may category, or, yeah.
Yeah.
It also, not only does it make the implementations more complex, but for people trying to learn about libp2p, it's like a whole new set of things they have to wrap their head around to feel they understand what libp2p is. So those are kind of the thoughts I'm having right now. I don't know, I need to sleep on it more,
and no, it makes perfect sense. It is a lot. I think going back to this like classes thing, let's put it all in one file.
Yeah, I think that'd be good. Yeah. Wait, I thought those comments were helpful. Why are you getting rid of those?
Okay, fine. I would almost like get rid of this.
Get rid of switch, okay.
Yeah, it's like underneath the hood, but I mean, I don't know. It's like
Okay. Yeah, okay.
If we expose it, then that like pulls out the guts.
Yeah.
So I would almost like remove it.
Yeah, I mean, someone trying to write an application on top of libp2p just wants to instantiate a node. I don't think they don't want to know how nodes work. So
yeah, I think they want to mount a protocol and they want to connect to nodes. That's it.
I mean, do they even want access to the Pure store, for example?
They may need to tell the node about peers.
Okay.
Kind of like, hey, make sure to connect to this. They may need to tell them about addresses, I guess. Although I guess it could be, maybe not.
I don't know. I'm just thinking aloud, but
well, they might want to be able to do is actually look at all the connections I have.
That's true. Which
is where the switch was from. Damn it. Because the switch like brings in all this other stuff about connections, and I guess we do need streams. We do need the idea of a stream.
You want to open the readme of JS here?
You have the entire interface there? Let me like kill this. It's not the amount of docs that count, it's the clarity.
Yeah, go to the API section. The example there. Which I guess answers the question from before. So if you go to the example, you see like libp2p itself. Like I say, I want to my special recipe on node with extensively here. And then I pass the modules that I'm interested in, like CPU, speedy, CPU WebSockets. And then I call the constructor. And then I say, okay, I create my name. And now I have my class.
Yeah, and I think that's probably how we want it to work in Go and Rust too.
Well, Go is doing the same. I think Go calls it host, but I think it's fundamentally the same idea. There's like
the host needs to be renamed into Node.
Yeah, I agree. Yeah,
but Go like you buy into everything. Like it doesn't let you easily to create a new recipe. Like Go is already a bundle.
Oh, I thought you could pass in to the constructor things that would override this default.
Always be changed. Maybe they change already.
I know they've done some work on the constructor like relatively recently. Yeah.
I think if you scroll up. Yeah, like you know that you start and stop because you have to start from the middle, you have to dial, and have a call when you like dial to a protocol enter to take off the connections. And you have like this peer routing, right? So now we need to trace the health of peer routing and for this routing.
I see.
Yeah, this is good. This is.
You also have ping in here? Yeah. And PubSub?
Yeah.
Yeah, see, if we had this in like an IDL, some neutral IDL kind of format, and then every language had to conform to it, I don't know, I think there'd be a lot of benefits. I think someone who wanted to implement, well, it'd be easier to learn how to use the library. If we had the same kind of standardized interface to like write a transport, then someone who wants to write the world's first, Morse code transceiver, transporter, whatever, something crazy, right?
Yeah.
They can write it in JS, Rust, and Go with the programming against the same APIs. Yeah.
Hey, I like that.
Yeah.
Morse code part?
Yeah. I was trying to think of something crazier than Bluetooth. So.
The thing is, like, writing interface definitions that they have no way to actually prove that the definitions are following them. It's kind of hard. What eventually happens, like same thing with the stream multiplexer interface definition. It's there. We actually even define for Go and JS. If you look at them today, they're different. Just because there's a lot of manual work. And either we have compliance tests, like so that the IDL has to generate not only the interpret steps, but also tests to make sure that like no one goes away from that. But like if we can get that, I'm all for it.
Yeah, I don't know a good automated way to test it. I mean, we can just, if we see that one language is failing to implement the standard, then we just start saying to that language, hey, you're
go scream right there.
Yeah.
Yeah, I mean, so there should be like two different lanes of tests, right? First, you have the test that you just assert within your own product that stuff is working, and that happens like on every change. But then you should also have, from the interface side, every time the interface changes, that needs to push out the test to the other projects so they can fix them when available. And then like open up an issue, and like, these are the tests failing, you need to fix this, like as soon as possible. But their normal build will still compile with that version that they're using, but we still make it available so they can use that thing. But it's also tricky, like we are having many different languages, and with the core implementations, it's easy because we usually have a HTTP API that we can kind of follow in an interface way. But otherwise, you need to write the tests in the native language, unless we use like hacks or something like that, and we can compile the tests to JavaScript or Go and Rust and stuff like that.
I think that I think we could write one test suite that connects to a live running thing. So if you have a live running libp2p node, then one test implementation can probe it.
So like then
RPC, right?
What?
As long as there is a standard RPC that every implementation.
No, you like boot the node, and you kill it. You like start a command line client, and then it like binds to a port, tells you what ports it bound to. So yeah, I guess you're right.
So like,
they write one program.
We can do CLI tests to make sure that CLI is the same. We can make HTTP tests to make sure that the HTTP API is the same. But when we were doing like the core definitions, like the programmatic API, that's when we either have to like compile to that language or like invent our own DSL with like YAML and then write our own kind of like generator of test cases that projects kind of like include.
And like, this is where this stuff is this stuff, right?
Yeah.
Yeah, but I mean, like that, we have to write a code gen for each language. Like, I'm just thinking,
and it could be also tests as well, right?
Well, I mean, that exists already as well, like hacks, for example, that compiles. I don't know if it does Rust, but I do think it does Go, and it does JS for sure.
But in these lower level languages like Rust, like people really want tight control over. Or, I don't know. Like, do you guys use code gen a lot in Rust or no? Yeah, it seems like you never. Yeah, I don't know. You know what I mean. Like in C, like people want very precise control. I don't know.
Yeah, it gets hard to test a programmatic interface in a language because that's when a language implementation will want to use idiomatic conventions. And yeah. What we could do is define, here's what we could do. We could define a standard interface that we can test that is just a bit of glue on top of whatever the idiomatic interface is. So like a language implementer writes the idiomatic thing, and then we write a small wrapper around that presents all the right methods. And so if they can't satisfy those, then there's something missing on the underlying thing. It's just kind of like mapping the idiomatic version to a standardized version.
I think this could work, and then high performance programs would just use what he's calling the idiomatic interface to Rust. Yeah.
So you will basically like wrap a CLI on top of whatever, like a library.
Yeah.
Like multi-hash, for example. You will wrap a CLI and then have a defined CLI interface, which then hopefully conforms with like what you're doing underneath.
Something like that. Yeah. I mean, I don't know if it would be a CLI per se, but yeah.
Or HTTP, it doesn't mean as long as it's something that like we can call.
Yeah. That's what you're proposing, right? Yeah.
Yeah. Well, I mean, what I was proposing, not quite in the CLI, but like I think you got it. Where there's like the idiomatic version that people use, and this other version, which is just one small file that just maps things and maybe massages the types a little bit, but should be able to pass the tests. And if that passes the test, then it's unlikely that the underlying implementation is wrong.
So they're both programmatic interfaces, but one of them is specifically intended to pass a set of tests. Yes?
So like, while we have the interface, and then we generate the steps for the language, at the same time, we just create the RPC for the sensor file. And then
yes, but the and it all makes sense. The constraint is that a language implementer will want to change the stubs and change the interfaces because it makes sense for that language. That's what we're trying to address.
It could be like interface stubs which expose the RPC again, and then the language implementer can change interfaces, but can still have machines.
Okay,
to define
got it.
interfaces, and so we can still use the same tests. To all
Got it. Yes, that could work.
But isn't this a bit like what Gherkin or Cucumber does, kind of? Like, because then you have your idiomatic language, whatever, and then you write Cucumber or Gherkin, so it's Gherkin's the language, and Gherkin wrapper, and then you basically have the...
Yeah, I think that's on a higher level, though.
Then it
Basically.
depends in a way, like, if the test is obviously too complex to express it in Gherkin.
Yeah, it's just like the language is
Gherkin,
meant.
I
Yeah,
guess?
it's cucumber. It's like a language to describe like scenarios for users.
So it's basically better for like integration tests.
So like this might be useful for like other things, maybe CLI tests or whatever, but maybe not the core interface stuff.
So we basically describe the words and then you do implementations for the words. So say like open connection, and then you have the open connection to code, which then does whatever it doesn't. Then I always want to play with it, but I never had the chance. I always bring it up when I get the chance.
Yeah.
Yeah, I mean, if you want to go play around with it and see if this like matches.
I find it funny, it's like a Java tutorial, and like this is like STEM. It's like pretty simple.
Yeah. Anyway.
It's basically a way of mapping sentences to code.
Change that to another language to see if the meaning starts.
Yeah, but it's very high level.
Yeah, it is, right? It's like for user scenarios. Right.
It's more like for non-technical people to
Yeah.
describe that.
Yeah, but I guess this isn't.
Yeah.
This is a bit different from what we were discussing.
Yeah, I don't think this is quite what because we're not concerned about humans describing the interface. We just want programmers to agree on an interface. So I think we can have a more IDL that's more like code. And
It's more about the behavior than the interface.
yeah, I think that's true too. Yeah.
That's right.
Yeah.
So like, doesn't already the HTTP and the CLI tests kind of like infer that the core implementation already has the available methods? Right? Like, what are we trying to achieve with the core interface programmatic thing, right? For JavaScript, it makes sense that the API and the core protocol, the actual code, you can call the same methods, but across languages, does that even make sense?
The reason is if somebody's an application writer and they're writing something across languages, it would be useful for them to have the same matching interfaces across languages to be able to easily port their application from one language to the other without having to learn an entirely new set of abstractions.
But for that, like the HTTP and the CLI compliance tests should be enough.
Not if they're implementing something by embedding the node. So IPFS, for example, embeds the libp2p node directly in itself.
Yeah.
And it wouldn't be using the commands library or HTTP. It would be embedding the functions directly.
Victor has an interesting. I was just gonna say he has an interesting point that like imagine a dev shop that says we're gonna write the same app on iOS and Android. They don't expect the same API. They know there's two totally different programming models, and they're okay with that. So I don't know.
I think okay is more like dealing with it than liking it. I mean, how many projects have been started to like try and like bridge those gaps?
Yeah.
It's like the rewriting Rust problem, right?
Like from my experience, so my experience comes from like Couchbase, they have the mobile client, which is for iOS and Android. And I think I need to double check, but I think they really opted for making it automatic for Android and for iOS. But because study that there are many people doing it too. But I think in the end opted to make it automatic because it turned out like it's like also if it's a shitty API for both.
Yeah. Fair enough.
Like, yeah.
Fair enough.
Yeah.
So yeah.
Like constructor in JavaScript or libp2p. Imagine that you have to create a factory for like because Java.
You need to inject a service into that factory. But like in the end, like if we have the HTTP compliant interface test or compliance test or whatever, and we have the CLI ones, why would we add another one? Like what's important is that the HTTP API is compliant, the CLIs are like working. If we just add another one, it's just maybe not getting a lot of value.
Right now, there's no HTTP thing for libp2p.
For libp2p?
Yeah.
No, because we don't have a daemon, right?
Yes.
Yeah. And it would be kind of
it
would be kind of painful to make every implementation of libp2p also have to write a daemon. But what we could ask them to do is write one
they're gonna end up writing something like a daemon, but it works over Unix sockets instead, or whatever. Like in the end, we're gonna have to expose something that the test can call, right? Might as well be the HTTP API, right? And then the four multi-formats need to do the same, right? Like multi-hash need to have either an API that the test can call, or a CLI, like a simple CLI, like conforms to the same standard across the languages.
But if somebody wants to vendor libp2p into their own code, like what, it's going to spin up this daemon?
No, so the daemon, so it will be the same as what JS IPFS does today, right? It's a CLI and it's a core implementation. Either you require it like programmatically or you execute it as a CLI. And what the CLI does is just mapping like commands to the core implementation.
Okay.
And then you can do both if you want.
Basically the simple layer mapping everything.
Okay.
Because it does almost nothing besides calling the core.
The CLI does nothing but translate.
Yeah, it just takes the arguments and passes them into the right way into the core implementation.
Okay, I understand.
I think gRPC did hit something really good with being able to define things across languages. God, where's the samples? Oh my God. What? What? No, but where's the gRPC thing?
The definition.
Where is it?
I don't know. Maybe it doesn't use protocol.
Is that Kelsey?
Message back or something like
Yeah,
that.
Yeah, okay. That's not
we
right.
need him well at Tucker.
Doesn't it work at the
No, I think he works at Google or Microsoft. I can't remember. I think he might have gone to Microsoft.
I think it's Google.
I mean, I know he worked at Google for a while. Did he leave? I don't know.
This used to be so well documented. What happened?
Material design happened.
Oh man.
So what is this? gRPC. Google RPC.
A lot of people call it that, but no, it's supposed to be general
RPC.
purpose RPC or something. Yeah.
I think it was intentional.
Okay, we're close.
Yeah,
we're
I
close.
think so too.
Yeah.
Yay, we made it. Here we go. Yeah, so this is a standard way, a protobuf like thing. gRPC used to be part of protobuf. Inside of Google, gRPC is part of protobuf. It's called Stubby, I think. But this is effectively what IDL that we were talking about would generate. And you can use this to generate out stubs and tests and RPC stuff and so on. It just is built on top of protobuf.
So I mean, this would just define like the top level interface, right?
Yeah.
How is that useful?
So this defines the top level interface, generates stubs for you, and then you can use this to generate all of the HTTP servers and like command line clients and all that kind of stuff. You can.
But still, you will have to take that server, map it to your core.
Yeah. So our commands lib and so on is like a part of what this can do for you.
Yeah. I think this helps us with like the easy part, but it doesn't help us with the difficult part, like mapping the interface to the core in each language.
Yeah, each language, for instance, the GS version of gRPC does that mapping as well as the Go implementation. So this is just a common DSL to define interfaces, but the mapping still exists in those implementations.
Yeah. So
like, how do you do a callback in this,
Yeah,
for example?
It has to
like,
be implemented in each language.
Yeah. It's just yeah.
That's right. So you would still have the idiomatic interface, and then you would still have a mapping from the idiomatic interface to this.
I agree with what you said earlier because, for instance, I was seeing the GS libp2p interface in terms of how do you add event listeners, which is on, and now we have off in version 10 of Node, and that's the idiomatic way to listen to events in Node.
Mm-hmm.
But for instance, in Go, I don't know.
Yeah, you would like pass in a channel and then you will listen to the channel outside of the
So
function.
it doesn't make sense to define a common programmatic interface.
Yeah.
Because people that are familiar with Node will look like that and, whoa, what's that? I'm not familiar with that at all.
Yeah, that's a good point, actually. Maybe we're wrong in thinking we need to define a single interface for all implementations. I don't know.
Like CLI interface makes sense. HTTP interface makes sense as well.
Yeah.
But then like the test cases themselves can be written in JavaScript or whatever, and then they call the interfaces that we have in the core implementations. And I think that will be enough to assert the behavior of the core implementation.
I don't know that all implementations should like implement an HTTP interface, for example.
Why not?
Why do we need like multiple of those?
Well, the point is to make sure that the daemons work the same across the languages, right?
So for libp2p right now, we don't have it. Suppose that we weren't planning to create a daemon for libp2p.
Yeah.
It's just a library. In order to use this kind of structure, we would have to then make every implementation map their interface to HTTP, as opposed to, which they're going to have to then do two things. One is map their implementation to a standard way of doing it, and then map the standard way of doing it to HTTP in every language. And so what this is suggesting is have these similar functions and then map your idiomatic thing to this, and then this handles all of the rest of the stuff, like the converting from this into having an RPC thing over HTTP or whatever you want to do, and it does all of that heavy lifting for you. Anyway, we don't have to bike shed this now. We can figure it out tomorrow or another day.
It will be possible to share like a zip binding, but that will be pretty slow to do that.
Yeah.
A what?
A binding to a C.
Oh.
But that will be pretty slow for pretty much everything.
I think a mapping could be really small. I think a mapping could be a single file of less than 100 lines. So I don't think it's that much to ask. What we should figure out is how would the other pieces work if we had that mapping, and could we get to the point where we can test everything reliably? If we can't do that, then we shouldn't be even exploring this. We should figure out if that is possible.
But a programmer who wants to use libp2p and comes in and it's a Go programmer and sees the node model of events instead of like passing channels, like idiomatic to Go, like this, they're going to be like, this doesn't make any sense. Like I'm trying to basically repeat what you were saying. Yeah. So, yeah, I see the advantage of standardizing for testing, but from the perspective of a programmer who wants to vendor in libp2p, not just use it as a daemon. But
yeah, I'm not suggesting get rid of the idiomatic interface. I'm saying have the idiomatic interface for sure.
Yeah.
Then in order to test it, we map the idiomatic interface to a standard thing.
Okay.
And then test that.
So it's just for testing.
Yeah.
Okay.
It's testing it and testing it for completeness. Because the test will check that it's correct, and will also check that you have all functions defined. And if you're missing some functions, you're not going to pass some of the tests.
Yeah.
So it really checks and makes sure that you have all the features implemented. Yeah.
Wouldn't it also make sense to have like some kind of if we're talking about integration tests that we can run against all implementations, like you can even run in JavaScript. Only the tests, and they run against all the implementations. You can write the test in whatever you want, but it would run against all implementations. In that way, it would be easier to be compliant because the tests are only implemented in one way, one language, and wouldn't be different for any, like Rust writes their own tests, and JS writes.
That's right. And so if we did have this, then we could just write the test once.
Yeah.
In theory. Sounds good.
And we get back to that language that compiles to many others, which is the one you said?
Hacks. That's right.
Yeah.
We have to brainstorm a little bit more.
Like for now, we have shortness, and we have some basic HTTP tests somewhere, I think, that we need to extract into its own repo. For now.
You mean the interrupt test?
Yeah.
That's like already on its own repo.
Oh yeah, that's true. Yeah. But there are we have to remove a couple of more tests there as well from JS IPFS API, I think, or something.
So we were like writing this one file that had everything. We said this is the majority of it, plus, but all of the networking.
Where is this coming from? Where is this?
My computer.
Ah. Can I just take your computer?
It's in gist somewhere.
Okay.
Yeah.
So the question.
What?
What is easier to find? Some gist?
Yeah. No, this whole thing is in a gist somewhere.
What I'm saying is that it should be on a libp2p issue.
No, because I didn't want. If I put in a libp2p issue, then immediately it becomes de facto like now another thing that can confuse people. And so I want to try and get it right with the people that are super loaded into the context, and then like push it out. You know?
So you can publish this part in your video.
Yeah.
You want to
this
share?
this like taints the whole recording, so now we have to like not show any of it. Great.
You want to share that just in Slack or something, though?
Yeah, I'll share it in Slack.
Cool.
Cool. Can I? Yeah, let's resolve this record store stuff, David, and figure out whether or not this should import IPLD stuff. It'd be really nice if it did for a whole bunch of reasons, but it is lumping in a world of stuff. So let's figure it out. All right, any last questions on how libp2p works? Everyone is now an expert?
Yay.
Can you give the next talk?
Everyone likes pull requests.
Yeah. If you get those interfaces right, then in Go, it would be really nice, like easy to take a Bluetooth implementation and then implement every one of those things, like the discovery.
Can you open the libp2p part?
The what?
do the search box. On the search, type interface dash.
Interface what?
Dash. Just a dash. Yeah. There's a scroll.
What?
There's like a
All of those in the top.
Yeah. Interface device. Connection.
Yeah, but I think we need to get these things to be.
Yeah, you want them all in one file. So there's like all the
I think
what it has, what it doesn't have.
I think this is the reason why people find it easier to like read the JavaScript project and understand like how the modularity works there, because this defines exactly how all the different transports should implement that interface.
Yeah, and like you can see, or sorry, all going to be on here, and then it's broken. This iPad doesn't work. Come on, here, all this transports and all of this interface. Taking a bench. That's
Yeah.
Which is what you want. It's like some interface that gets followed by modules, and then can be pulled in.
Yeah.
It's not.
I
like,
don't know that I want people to have to read hundreds of lines of text to understand these interfaces.
That can be a dream version. But like, as long as it's all automated to learn, right?
What's that?
There can be a dream version, like a summary version, as long as it is auto-generated from whatever type or something. The thing is, like, it's just like too manual right now. Just like cumbersome.
Yeah.
Like you want to update one thing, and suddenly you have to like issue 15 PRs.
And test. No, and make sure that it hits test.
Yeah. So those repos are also tested.
They come with tests that then the implementation is like
Import
imports
and
in
run.
their test runs.
That's when they get the badge. They don't get the badge.
But you manually add the badge.
Yeah. Paste some markdown.
All right.
But probably in the README we should just have the Go interfaces instead, because this is way easier to read than the markdown headers and code blocks and stuff. Like this you see directly like exactly how it sounds.
Yeah, fine. Send it to me. Or I'm interested to explore.
I mean, do you think that this is like a good summary?
No, like it's a good summary.
What's missing?
Just like when you say libp2p node is assigning.
No. Sorry, I don't mean like the document. Like each of these would have like a large document, like a comment explaining how it works. Like you've seen how Go code gets documented, right? What? Yeah, but even more than that.
The whole purpose of making only code is to be shorter for people that have to read a large document to understand.
No, mostly the code is for us to like agree on it and use this as our spec.
It's more for internal
Yeah. You can then create tutorials and all that kind of stuff.
And I think like there's a lot here. There's also like no bias versus yes bias.
What's idiomatic? What stuff here seems to you idiomatic to Go?
Like mount protocol, for example, is gonna return probably like you pass in a channel or it returns a channel, where in JavaScript you would have a callback, for example. Like Go routines versus callbacks. And
so just like the
HTTP.
calling convention to an error?
Yeah, returning multiple things, peering for an error, for example.
I'm not even like thinking about like each line. I'm thinking about how to present an interface. Like in JS, people are used to have a line that like shows a function signature, like which arguments are optional, which are not. Within below it, and so that's like what people have been doing for a while. And so like that stream of text that you were saying, that wall of text is not that bad.
Well, there's a big difference in a language that doesn't have types than a language that has types.
So like get create equal, right? It's just like three lines.
Yeah, but I think we can.
No, but I can't check that. I can't use that to check it against anything.
We can express this in like a more concise way as well as have the long description, because like there are two different things here.
We want compilers to check this stuff for us.
Which this works well for, right?
Yeah.
But then there is the other side of the story, which is people wanting to understand why or what or whatever.
So this would get mapped to a JavaScript implementation, would have its own idiomatic version of this, and the JavaScript implementation should be documented. So you should be able to look at the JavaScript implementation and only read that, and only use that.
I don't see any problem.
Now,
in terms of having this code just to agree on and then import that to.
Me neither.
It works.
I think a user of libp2p in a language would read the documentation of that language. An implementer of libp2p in a new language should read a file that gives them all of the context necessary to write to like do the mapping.
This would be thing that goes into ours. It's just like one more language. As many languages
Yeah.
that exist in RFC and papers describe interfaces without spreading it to the actual.
This isn't even the stuff that's going to go into the Go implementation.
I know.
The Go implementation is going to have a bunch of other stuff.
But I'm saying like this is actually normal. Like if we think that this is going to go to the RFC.
Yeah.
Then like a lot of RFC that kind of like DSLs that are like real, there's just like a way to expect something to real.
Yeah.
This could even be C# or something like that. Just
Yeah.
a way
Or
to
could be
test types. Just
Yep.
yeah, maybe in imaginary language.
So, but I guess what I was asking is, are these types all we need? Pure ID, pure info, multi-adder. So I guess let me pull in.
Isn't the whole thing of returning a tuple of return type and error kind of a Go idiom?
Yes.
Like, yeah, okay. So
That's just because we're using right now Go as the IDL.
Oh.
If we used something else as the IDL, we wouldn't write that.
So I just stepped out for like 2 minutes. I think I missed some key part of this.
we referenced that exact thing. Yeah.
Okay, all right.
So, yeah, because if this was JavaScript, we would say.
promises.
Yeah, exactly.
So in JavaScript, you have like JavaScript, the callbacks version, and then, you know.
Fun facts. We actually do that today. Right? It's like ping full stream, ping stream.
Yeah, but that's because of the stream types.
Yeah.
So not only like the async promise versus callbacks, but also which stream you're using, readable stream or full streams. Yeah.
Anyway, pure ID, pure info, pure store, pure discovery, content discovery, pure router, content router, the node. I guess we need the crypto. We need the keys.
Can you move back to the other on the bottom? What's that swap card? It's a pointer?
Yeah, sorry.
Okay.
That's an idiomatic to go thing that we can get rid of.
So now so what we must have decided while I was out is we're going to turn this into, we're going to get out of Go specifically and turn this into some more generic. I'm just trying to infer what
I think we should use Go for now. Like, is anyone opposed to using Go for the interface definition language? David?
I don't really care. I just want to mention that there's also like the IDL from Mozilla, and it seems to map to C++ and JavaScript, which might be what we need. Like just.
Yeah, I've seen that.
So I have no clue how good it is, but just like to mention it. Like.
Uh-oh.
There are a lot of ideas.
Oh, that's like.
This is something else, though.
They have CIDs, man. Oh, sweet.
Search for WebIDL. Search for WebIDL is the new one.
It's the one that's also used on the W3C specs, right?
Well, it's used for Firefox OS, therefore I'm.
Yeah.
Oh no! Oh no! Oh my God!
This is what you have to use. This is what you have to use.
Are you serious?
No, it's the same thing.
Constant attribute separation.
Yeah.
I think there is like a better page maybe than reading through the specs at this
Yeah,
point.
I know. Well, it's updated. After last month.
yeah, look at those files. I mean, those should be examples of the, like, WebIDL should be the, yeah, so it's just.
Portable promise. David, yeah, that's what we need. Yeah. Just solve cancelable requests.
Portable.
That's a too small one, I guess. That's not really.
This is the abort controller, no? Has to be, has to be the abort controller.
I think this is even more idiomatic than Go. Like callbacks.
Yeah, I mean, this is for defining JavaScript things.
For the web.
No, like it's for it's also for C++, but like it's for the C++ side in the browsers basically, and like it is the API for the JavaScript side, but of course the browser needs to implement the other side in C++. Anyway, I just want to bring it up in case you were aware of it, but like just So I mean,
I don't think it's a bad thing to bring.
I mean,
It's a great thing to bring up. There are other IDLs that we should also look at.
This was all the information I went to.
The only reason I mentioned Go, or like we landed in Go, is because it's really simple. Not for any other reason.
It is super easy to understand.
Can you rename connect dial?
No. That's a different semantic thing.
We already talked about it.
Did we? I don't remember.
2 years ago. I dial everywhere.
What's the difference between connect and dial? I actually thought they were the same.
Yeah, dial is the explicit outgoing connection, and I'm making I'm telling the interface that I'm explicitly going to make an outgoing dialing call. And so that means do some setup and perform a dialing operation. Listen is the symmetric equivalent of that, which is do some setup and await a connection, and then get ready to accept connections. Connect here is actually ambiguous and says, I don't care how you do it, whether you dial out or listen in, just connect to this peer. If you already have a connection, this just returns right away.
Oh, I see what you mean.
So if we call this dial, that'll cause confusion.
So you're basically saying connect is idempotent and dial is not, whatever the opposite is.
Yeah. You dial addresses, you connect to peers.
Oh, okay. Okay. Yeah, I see what you mean.
This is definitely a bike shed word like
No,
thing.
but this was good. Because I noticed this debate going on in other places. So
Like I would like to expose an interface that does not have all of the connection stuff, like at all. I would be really happy if we could do that. I don't know that we can. And we may need to think about like, should there be protocol handlers? What do we want to think about this? This is an experiment.
I think we should think about who do we want to use libp2p besides IPFS, and then kind of work backwards from there. Like what sort of interface they want to see. Do they want to write their own transports? Or from their point of view, is the benefit that they don't have to write transports because we've already created them? I don't know. I see a lot of directions we could go, and there's actually a lot of different ways to use this. Like you could vendor this into your code. You could run it as a daemon, either because we built that or you build a thin wrapper around it. you can plug into it in the sense of writing transports, versus calling it from a higher level of abstraction down. So I don't know. Sometimes I feel like we have to think through what those use cases are. And,
Yep. Especially the protocol, like how do people want to write protocols on top of it? We have one implementation of that is kind of modeled after HTTP servers in Go specifically. It's not necessarily the best way to do it. Actually, HTTP servers in Go and JavaScript callbacks. So it's a callback-oriented thing. It may not necessarily be the best one.
Sorry, when you say we have one implementation on top of this, you mean IPFS or RevVoid?
No, I mean this mount protocol thing. The way that works is using callbacks as a way to like grab my protocol and mount it.
Okay.
That may not be the best thing.
Do you do that in Go as well?
What?
Do you do that in Go as well?
Yeah.
Not channels.
No, dude. In Go, with anything high performance, you do not want to use channels. Because they're actually quite expensive. Unfortunately, Go channels are quite expensive. The version 1 of libp2p in Go was written with channels, and we would take a packet. Like, this all started with trying to make a packet switch at the beginning, and we take a packet and send it through channels and so on, and like do all of this kind of stuff and then deliver a packet to the protocol, all in normal idiomatic Go stuff. It was horrendously slow. It was awful. Muxado, which is yet another stream muxer, by the way, did the same thing, and at first it was all idiomatic to Go. We did it around the same time, and both like abandoned it completely and went the other way because channels are surprisingly expensive.
But is Go intended to be high performance? I thought the point was to make concurrency like simple at the expense of this is not C++ kind of.
Well,
is that wrong? I don't know. I don't know the
yes, but I think that they are probably unhappy at how expensive channels actually are. In that they would have preferred this to have been good enough such that we could have written that implementation with channels that way. But in this case, it was just so bad that it just wasn't reasonable. So,
but I mean, maybe we should put more effort into our high performance. Oh, they left, but our high performance Rust implementation. Like maybe.
They're right there.
Oh, yeah. I mean, I don't know. No, it's just an observation. Like maybe that we have performance requirements beyond what Go is ever going to reach because that's not their objective.
Yeah, I mean, I don't know that Go. That the runtime without channels actually is much slower. That would be a great question. We should figure out, like, we should actually benchmark them and see how they do.
Benchmarks at the moment
What's
that
that?
you could run against the CLI or against the protocol itself, HTTP or something like that, and measure the differences between Go.js and Rust. Is there any?
Not right now, but we should have that, definitely.
It will be interesting to see the performance of
Frito did that maybe 1.5 years ago when we were doing the NPM stuff. We did some benchmarks. Not sure what that did. And it's probably super old.
Yeah. Go is probably within, for most things, within an order of magnitude of C at most. In most things, less than an order of magnitude. Most things that are I/O bound won't, like, Go will be fine. I think Go doesn't do as well when you have a lot of function calls and you're manipulating like Go routine stacks and potentially switching from Go routines. But if you're dealing with I/O, it's going to be probably close. We should benchmark it and see how it goes.
Yeah, I mean, it's just a thought of where do we want to put in effort. But yeah, I mean,
definitely, if we want this to be in a router, for example, in like an actual like network router, it's going to have to be Rust.
Yeah.
Like nobody will admit a GC.
Yeah, I agree. Yeah. Yeah.
We
So.
need a common interface, and then for the benchmark, we need a common interface.
Oh, just measure fairly, yeah. See where you're going, yeah. Yeah.
It's all
Yeah.
related to the tests.
Speaking about the interfaces, is PubSub not supposed to be here?
It is supposed to be here. Whoops.
Uh-oh.
It's there.
Sweet.
Trying to damp vibrations.
Thank you. That was bothering me all day.
So accept messages to like run in a loop to like get the next message.
Yeah, and so this is explicitly a different way of doing it than the handler callback, because I wanted to see what that would look like.
Cool.
Yeah.
Is the NAT stuff part of like some interface?
What is?
The NAT traversal things? Or is that like
I think it would be a specific underlying. That would be kind of like you write a special transport that is NAT traversal aware,
right?
And then it tries to make the connection happen. Because there are a bunch of different NAT traversal strategies.
Yeah.
But that's a big selling point potentially for the library that we have all the natural traversal strategies built in, and we'll try them one by one, something like that.
That's right.
Yeah.
So
but do we have any transports that actually do what I just said?
We have a couple of NAT traversal things. One of them is the very trivial like UPnP and NatPnP things, which are like asking nice routers to open a port.
Okay.
We have a really painful thing where in TCP, as originally designed, you can send and receive from the same port. And if you do that, and the NAT that you're dealing with is not fully symmetric, then after you dial out a couple times, you can observe the same address from the outside. And then you know what your address outside of the NAT is. So then people can dial you. This is how hole punching works. So we do like lazy hole punching in that as you dial out, you're going to hole punch.
Oh, and this is just a quirk of the spec that routers are implementing, or what?
No, it's meant to work that way.
Oh, okay.
It's meant to work that way.
Okay.
In Go, the network stack does not allow you to reuse the same port. Actually, it does not allow you to bind on a TCP outgoing port if that is already bound to a listener. But the kernel lets you do that. And so you have to set a kernel flag, like a syscall flag. And currently, it's there's like an annoying module that exists to deal with the language limitation.
Oh, okay.
Yeah,
Not written by us. You mean somebody else?
Written by us.
Oh, written by us. Okay.
It was between forking the language and maintaining a patch on the language, where like we download the latest version of the language, apply the patch, and then run it, and convincing them to change their mind, and writing that module. And so we wrote that module because that was the cheapest version, but it's been no end of
So that's
pain.
the SO reuse port.
That's right.
Yeah.
Yes, yeah. I think for the kind of sophisticated stuff we're doing, Go doesn't feel like the right language, but I recognize that it's extremely popular, and we would lose a lot of potential downstream developers if we didn't support it. So it's a real trade-off. It's like,
Yeah, I mean, I
don't know.
really think it should be, Go and Rust should exist.
Yeah, I see. There's
And
room
JS.
for both of them. Yeah, well, JS we need in browsers, so that one is easy, I think.
Though with WebAssembly, we can have JS, Go, and Rust in the browser.
Yay!
It's coming. Oh, you want to see something awesome?
Always.
Well, with WebAssembly, would we stop developing JS and just do everything in Rust and target the browser as one compile target? I mean, sorry, is that crazy or?
Yeah, that's totally legit.
I think we would have specific transports for the browser that you won't do on the in desktop.
Oh, that's
right?
a good point.
So
yeah.
like WebRTC, for example, you would only do in the browser.
Yeah.
And that comes with like stun and some other things. So maybe we would use like a base, but then bundle different things, and then those bundles could be written in JavaScript.
Would those be handwritten JavaScript, you mean? Or they
Yeah,
just
I
be
mean-
Rust?
Or
Is-
or there are Rust that like
Yeah.
calls into
Is David
JavaScript.
here?
John.
David, check this out. This is wasm bindgen. So there's a main.html here that is going to pull in /out/main.js and /main.js. Main.js here defines greet equal to wasm bindgen, and then it has a function called runapp, which calls greet. And then it has wasm bindgen, something, something, then runapp. So it calls wasm bindgen, which is a function imported somewhere. And then after that, calls runapp. All right? So then here I have a lib.rs. And so here I do some wasm bindgen stuff. And then I extern an alert function. And then I define the greet function and I call alert from greet. So I can build this. And it built main.js here, which has a bunch of it has exports.greet and so on. Probably somewhere runapp is calling greet in here. Yeah, here. Maybe it got compiled out somehow.
No, up, slightly up.
Where?
4039, wasm.greet.
Yeah, here you go. Well, this is the JavaScript version of greet, is like taking a JS string and turning it into a wasm string, and then calling wasm.greet. And so here's a bunch of wasm. Oh yeah, here you can see that very important operation. And then you have this great, amazing slide that whatever. Woo!
It's like a musical number.
It's very long. This is just greet. Wow.
It's probably burning a lot of runtime stuff.
Yeah, I know. I'm kidding.
Memory allocator.
Yeah, it's probably.
Yeah, because it did some stuff. So yeah.
And then we run it, and it says "Hello World."
Whoa.
And you can go to Rust and be like, "Oh, you know what? I want to make sure that this is legit."
What?
Save. Build. Thank you. Yeah. So this is pretty sweet. So yeah, I mean, Rust implementation of all this stuff, it's going to be on the browser. It's going to be sweet. I mean, they already showed it, right?
But what is special about wasm bindgen? Is that
Well, it shows you how easy it is to call functions from one to the other, right? This is calling greet with a JS string, and over here you're getting a Rust string, I think.
Yeah.
This reminds me on the old days, on the Flash.
With like action script.
Yeah, action script where we call methods, GS methods, and from the Flash and GS and the other way around.
Yeah, exactly.
Yeah. Can you do networking?
From WebAssembly?
No, I just went away that when doing REST WebAssembly to also create some JS process, even if it's a service worker or whatever, just to limit where
Well, I mean, you would shell out to the native functions of JavaScript.
Is that, yeah, but I want that to be easy. I want to be able to say, I want the WebSocket right now. And
Why?
I don't want to think that I have to.
to be useful, this needs to have like a foreign interface where you can call like a host platform, right?
Yeah.
Which in Wasm would be the browser, right? So you have
You
access.
talked about this, right?
He was using AppScript, so he did never went to WebAssembly.
Because
So yeah,
they have a problem with
what
WebAssembly doesn't.
what the WebAssembly guys want to do is create a features thing where you select which features you need from the environment.
from the environment. Yeah.
And so that would be a networking feature or something.
But currently there is no environment, right? That's the.
You have to inject functions manually.
That's why you
JavaScript.
couldn't really use it, right?
We can use it if we generate this automatically. Of course, if you do everything manually, it's super painful, but if you generate code automatically, it's efficient. We just didn't do it because it's not idiomatic and everything, but it's definitely.
So the Mozilla Hack blog has a lot of sweet articles about Wasm.
Yeah. And Wasm Bindgen is going to probably pull in C and C++ as well. Potentially other things.
Oh, so this site is just this whole site is just demoing Wasm Bindgen? Okay.
No, this whole is like a...
This is some kind of general IDE, and it's just saying.
Yeah. Empty what projects?
Oh.
I don't know. Oh, maybe it does always do bindgen. Maybe yeah. Maybe this is.
Okay. Okay.
What is the human readable version, right?
What's that?
What is the human readable version of WebAssembly, right?
Oh, I see.
Oh, so actual WebAssembly is just some binary format, or what? Or it's just.
It's what you saw there.
Oh, it's
WebAssembly
literally that
text.
text, like
all that assembly like
add,
stuff.
conf, like okay.
Yeah. But
Okay.
you have the what version that's kind of human readable.
Oh, okay.